Greetings! In today's lesson, we will explore how to tackle systems of linear inequalities. First, we will define what is meant by a system of linear inequalities in mathematics. We have learned to solve inequalities. One form of inequality is the double inequality. Let's look at an example of it. Is greater than or equal to 2 but below 3. What does this imply? We need to write down such values for the variable y in our answer that satisfy the condition. These numbers constitute a collection of numbers that are greater than or equal to 2 and less than or equal to 3. We are aware that this interval can be illustrated on the number line and expressed as a numerical interval. Let's begin by illustrating this solution on the number line. What will we do? We will indicate the points on the number line at coordinates of 2 and 3. Let's observe that these points will be filled in, the point 2 and the point 3. Note that we must correctly position these points on the number line at coordinates 2 and 3. Since 3 is greater than 2, point 3 is positioned to the right. Now, to present this interval, we will move on to demonstrate it. Now, we are discussing all the values of y, that this interval will be from 2 to 3. Every possible value of our variable y must meet the following requirement. I must be at least 2, but no more than 3. We can solve these inequalities. But I want to point out the next form of this double inequality. If we consider this inequality in this form, if I close the right side of this inequality, then we will end up with the inequality y greater than or equal to 2. If I limit this part of the inequality, then I can write that y is less than or equal to 3. Notice that our variable must simultaneously be greater than or equal to 2 and less than or equal to 3. If this condition is satisfied simultaneously, the values of our variable will be at least 2 at the same time. And the variable value is 3, which is shown as a double inequality. This double inequality can also be written individually. However, in this case, we merge these two inequalities using a curly brace. If you see a notation that includes an inequality and a curly brace, then such a collection of inequalities is called a system of linear inequalities. In order to resolve this inequality, we will utilize the coordinate line. Let's go. We will arrive at the same answer, but by solving this system. What steps are necessary? We will separately solve the first inequality. Y is greater than or equal to 2. We will show the solution on the coordinate line. Look, I am showing point 2 on the number line. We denote it with a filled dot. All solutions for this first inequality will be located to the right of point 2. But the condition also states another. Inequality, y, 3. Let's demonstrate this inequality. I indicate point 3 on the number line. Thus, the solution to the second inequality will be the interval, which is located to the left of point 3. But we discussed that when we solve the system, we find values that satisfy both the first and the second inequalities. How can we see these values? The thing is Imagine that I connect these two coordinate lines. I superimpose one coordinate line on the other. Let's match the first coordinate line with the second. What do we get? Point 2 is here, and the variable values are to the right. I demonstrate these values through the use of these lines. And what do we see? The simultaneous solution and the first and second inequalities. It is contained in this interval from 2 to 3. This value u, I will indicate that u is included in the range from 2 to 3. Let's compare our answers now. They match. Therefore, when we see a system of inequalities, to solve this system, we need to first solve the first inequality and then the second, and integrate the graphs of these solutions. And then we will see the interval in which the values of the variable will satisfy both the first and the second inequalities. This is how we will solve the system of inequalities. But in our next lesson, we will examine different methods to solve our inequalities. For now, our lesson is over. Farewell, until next time.